Hello friends, welcome to our channel. I hope you are all in a very good health and doing well with your studies. Thank you for joining me. Today we are going to solve some important questions from the chapter Ratio and Proportion, class 10. Let us take our first question. So this is our question. Now we can use the given information. Let us write x by b plus c is equal to y by c plus a equal to z by a plus b is equal to k. Let therefore we can write x equal to k into b plus c, y equal to k into c plus a, z equal to k into a plus b. Now we can put the values of x, y and z in this relation. So let us first take this expression. Therefore a by y plus z minus x is equal to a by y plus z minus x. So we can take k common from all these quantities. Y, that means c plus a, z means a plus b, x means b plus c. So this can be written as, so plus b and minus b can be cancelled, plus c and minus c can be cancelled. So it gives us a by k into 2a. A can be cancelled, so it gives us 1 by 2k. Similarly, let us take the second expression. b by z plus x minus y. K common. So the value of z is k into a plus b. The value of x is k into b plus c. So this is b plus c. The value of y is k into c plus a. So C minus A. Okay, this is what we get, equal to B by A into so this is 1 by 2k. Similarly, if we put the values of xyz in the third expression, we shall also get 1 by 2k. So similarly, we can write C by x plus y minus z is equal to so this gives us 1 by 2k. So we can see that each expression is equal to 1 by 2k. So we can say these expressions are equal. Therefore we can write A by y plus z minus x equal to B by z plus x minus y is equal to C by x plus y minus z. Okay. So this is proved. Now let us proceed to the next question. So let us write let us say x by a, y by b equal to z by c is equal to k. Let therefore we can say x equal to a into k, y is equal to b into k, z is equal to c into k. Now if we put these values in each of these expressions, we get so if we take k square common, we are left with a square minus bc, and again in the denominator we have a square minus bc. So these two terms can be cancelled. So it gives us k square. Similarly, y square minus zx by b square minus ca is equal to so b square minus ca can be cancelled, so it also gives us k square, and the third expression z square minus xy by c square minus ab. In place of z we can write ck, and in place of x we can write ak, in place of y we can write bk. Sorry, this is c square minus ab. Okay, so this is c square minus ab. So the third expression also gives us k square. Therefore we can say that these three expressions are equal. Therefore we can say proved. So this is proved. Now let us proceed to our next question. So this is our next question. Let us write the given information first. So this is given. Now we can apply componendo dividendo. By applying componendo dividendo we get, okay, componendo dividendo means numerator plus denominator by numerator minus denominator. Okay, so in the left hand side, numerator plus denominator by numerator minus denominator. Similarly, in the right hand side, numerator plus denominator. Numerator minus denominator. Or we can write 2 into a plus b, and in the denominator minus c plus c minus d plus d. So we are left with 2 into a minus b, and in the denominator or 2 into a plus b by 2 into c plus d equal to 2 into a minus b by 2 into c minus d. So 2 can be cancelled. Similarly, in the right hand side, 2 and 2 can be cancelled. So we are left with this: a plus b by c plus d equal to a minus b by c minus d. Now we can do one thing. Okay, we can write it like this: a plus b, this term can be taken to the left side and this term can be taken to the right side. Okay, Now if again we apply componendo dividendo, again by applying componendo dividendo, we get a plus b plus a minus b by a plus b minus a plus b. Okay, so when we apply a negative sign before a minus b, the signs of a and b get interchanged. So a becomes minus a and plus minus b becomes plus b. Similarly, in the right hand side, c plus d plus c minus d, c plus d minus c plus d. So it gives us 2a by 2b equal to 2c by 2d. So we can cancel 2. So now we are left with a by b is equal to c by d. That means we can write a is to b is equal to c is to d. So this is what we needed to prove. So it is proved. I hope you have understood it. Now, friends, let us proceed to our next question. So this is our question. Okay friends, now let us try to solve it. So we can write from this given information, we can write x square equal to by plus cz. Now we can add ax to both sides of the equation. Why we are doing it? You shall understand it very soon. So x square plus ax equal to ax plus by plus cz. From the second relation we can say again we can add by to both sides of the equation. And from the third relation we can write we can add cz to both sides of this equation. Okay, now so this is what we are getting. This is the first relation, this is the second relation, and this is the third relation. Now we can write a by ax therefore a by a plus x can be written as, okay, if we multiply the numerator and the denominator by x we get similarly from the second expression b by b plus y, if we multiply the numerator and the denominator by y, this gives us by 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 plus y square, and c by c plus z. This is our third expression. If we multiply the numerator and the denominator by z we get cz by cz plus z square. Now in place of ax plus x square we can write ax plus by plus cz. Again, in place of by plus y square, we can write ax plus by plus cz. And again, in place of cz plus z square, we can write ax plus by plus cz. Now if we add these three ratios, we get ax by ax plus by plus cz equal to plus by by ax plus by plus cz plus cz by ax plus by plus cz. So the LCM is ax plus by plus cz, and the numerator becomes, so the whole quantity in the numerator and the denominator can be cancelled out, so it gives us 1. Sorry friends, I have made a mistake. Okay, in place of equal to, it should be plus. Okay, so this is what we needed to prove. Okay. So we can see that if we add these three expressions, we are getting 1. That means this quantity plus this quantity plus this quantity is equal to 1. This is what we needed to prove. Therefore we can write a by a plus x is equal to b by b plus y is equal to c by c plus z is equal to 1. So I hope you have understood the solution. please go through the question first, and then try to understand the solution. Now friends, let us proceed to the next question. So this is our question number 5. We need to show that each ratio is equal to 1 by a plus b plus c. So let us first write the given information. Now, if we apply the property addendo, we can write these ratios are equal to a new ratio whose numerator, the numerator of the new ratio should be equal to the sum of the numerators of the previous ratios. So this is our new ratio, okay, and the numerator is equal to sum of the numerators of the previous ratios, that means x plus y plus z, and the denominator of the new ratio is equal to the sum of the denominators of the previous ratios, that means xa plus yb plus zc plus ya plus zb plus xc plus za plus xb plus yc equal to okay, from these three terms we can take a common. So we can write a into x plus y plus z plus from these three terms we can take b common. And from these three terms we can take c common. Okay, now if we take x plus y plus z common from these three terms, we are getting in the numerator this, and in the numerator x plus y plus z. So these two terms can be cancelled. So this is equal to 1 by a plus b plus c. So we can see that each term is equal to 1 by a plus b plus c. This is what we needed to prove. I hope you have understood it. If you have any question or any doubt, you can leave that in the comment section. I shall definitely answer that. Thank you. That's all for today. Tomorrow we shall come with another video. Thank you, friends.